So if your greenhouse were in production 52 weeks out of the year, the method you just saw would be great. But we all know that most greenhouses are not completely in total production 52 weeks out of the year. So if we return to page 5 of your text, you'll see in table 5 that there's table 5 that there is a method to calculate square foot per week based on the actual greenhouse production. So we saw in the previous example that you had 51,000 square feet of production. In January, the percent of that area that was used was 25%, and that lasted for 5 weeks. So if you multiply those three numbers, 51,000 times 25% times 5, you find out that in January, 63,750 square feet of the greenhouse was used as opposed to the 51,000. Then if you continue and calculate that square feet weeks for each month, you'll realize that in a year's time, 1,522,350 square feet weeks were used. Square feet weeks is the number of square feet times the number of weeks, if you will. So it's kind of a concept that you're going to have to stop and think about and process because we don't use square feet weeks as a unit very often. But it's something that you have to calculate if you're going to calculate the overhead fixed cost. So if you take the total overhead cost or the total fixed cost that we saw previously of $280,424, then you divide that by the total square feet weeks, then you will find that the actual cost per square foot per week is 18.4 cents as opposed to 10.5. So the calculation of cost per square feet using the method here is much more efficient and much more correct than the method that we used before, because the first method doesn't take into consideration that there are times when the greenhouse is empty. And if you don't include the fixed cost for when the greenhouse is empty into the fixed cost, then when you come up at the end of the year, you may come out short and not have the money that you thought you would have to pay the bills. Once you know what that fixed cost is, then you can start applying that fixed cost to the particular crop. So back to our poinsettia example, and I'm on page 6 now. If you were to look at the 8-inch pots, you'll see that for 4 weeks of production of an 8-inch pot, you need 0.62 square feet. If you take that, you multiply it by the number of weeks, then you will get a total of $2.48. For 11 weeks, those pots need to be spaced, and they will take 2.5 square feet or 2.5 square feet. And when you multiply that, you'll find that the total square feet for the last 11 weeks is 27.61. Now, if we add that together, we find that the total square feet weeks to produce an 8-inch pot is $30.09. On the last page or the last slide, we said that the cost per square foot per week was 18.4 cents. So if we multiply 18.4 cents by the number of square feet weeks, which is 30.09, we'll find that the total fixed cost for an 8-inch pot poinsettia is $5.54. Page 7 of your book shows an example of the inventory method for calculating total square feet weeks. The advantage to using this method as opposed to the previous is that this method takes into account different seasons. So as you can imagine, in the springtime of the year, your cost is probably going to be less than in the winter months because your heat bill is going to be less. So for your spring bedding plants, your fixed cost or your overhead cost isn't really as much as if you were growing, say, poinsettias or tomatoes in the winter. So if you need to break that down, the method you see on the screen will let you get even more specific and get a more accurate fixed cost. Once you know what your variable costs are and what your fixed costs are, you would think that you could then set the price for what you would sell your product for. But realistically, we can't do that until we determine something called shrink. Regardless of how careful we are and what methods we use, we still are going to lose a few plants, and we need to take that into consideration whenever we do pricing. So to calculate the shrink, you would use a table such as this one that has production multipliers. And so in this example, we're going to assume a 3% shrink. So we take our variable cost of 64.7 cents. We take our fixed cost of $1.707. We add those two together and multiply by the percentage shrink, which is 1.031, which will give us a cost of $2 and roughly 43 cents. And so if we charge $2.43, we are now taking into consideration the plants that we didn't get to sell. So finally, you're ready to look at profitability. And to know if you're profitable, you will have to know what the break-even price is. So the place where your total cost and total variable cost and total fixed costs are added together is what is known as your break-even point. Beyond that point, you will then recognize a profitable business. Below that point, then you're not profitable. As a matter of fact, you're losing money. And so if you look at the example on table 9, you'll see the variable cost for 4, 6, and 8 inch pots. You'll see the fixed cost, and that will give you your total production cost. What did it cost to produce that plant? Of course, we mentioned you want to include in your shrink multiplier to account for those plants you might lose. And then here you'll see that you have break-even cost of 1.92, 4.24, and 7.99. So if you were to consider this, you could then move on and calculate the gross revenue per square foot by determining the square footage needed for each of these pots. But for our purposes in this video, we're just going to look at the break-even cost. So if you had a 4-inch pot and it cost you $1.92 to produce, you would have to consider what you wanted your profitable margin to be. Well, obviously, if you wanted your profitable margin to be 10%, you would multiply the break-even cost by 10%, which would give you 19.2 cents, and then add that additional profit back into your break-even cost to give you the price to charge to your customers. And if you need more information on how to calculate profit margins, there is a multiplier table on page 9 of this chapter. So in conclusion, just remember that by midnight Sunday you need to complete the Chapter 2 handout, and then there is a Chapter 2A assignment which requires you to go online and find a greenhouse budget, then take the values from that greenhouse budget and calculate the variable cost, the fixed cost, the break-even cost, use a shrink multiplier. You can find the instruction for this under the content tab for this week. As always, be sure if you have questions, get in touch with me, and I hope you guys have a great week.